Welcome to a new video. Today we will discuss the digital input for our PLC or DCS, the types and how we wire them inside our panel and all the way to the field. What type of digital input we are talking about? So we're talking about the field. You have level switches, pressure switches. On your valves, you may have limit switches for open and closed position. Your panels will give you an alarm for the pressure inside the panel or the temperature inside the panel, or if you have a power supply or network switches. Your equipment will send you alarms, statuses. Your MCC UPS also will send you a digital input. Here we can see different type of our devices. Limit switches, selector switch. This is a temperature switch inside our cabinet, a relay or a contactors, level switch, pressure switch, and a push buttons. There is mainly two forms of digital input. The dry contact, that means this provide you with a dry, non-powered contact. Is it open or closed, or normally open or normally closed? The other form is a powered device. That means this device itself needs power, and hence it gives you back one of your power lead. You can look at in simple way. For the dry contact, your card will send an AC voltage or a DC voltage, the plus side or the minus side, and then the dry contact will return back this power which is you fed it to the dry contact. 3-wire proximity switch and 2-wire proximity switch. There is two types of 3 wires, which you give it supply voltage. 2 wires for the supply voltage. So you send the, let's say 12 volt or 24 volt. Then the signal comes back as your supply volt positive side. The other type is it's returned back to you your negative side. Then the 2-wire transmitter, it acts as it is a variable resistance, but in fact it is two types or two values of resistance. A resistance when it's on and a resistance when it's off. So when it's off, it's high resistance. When it is on, it's a low resistance. We'll go through all of these in our few next slides. From card perspective, you will have a digital input card with isolated channels. So each channel is completely isolated from the next one. The common, we have one common side for all your signals, and then the return for each one is separate. The first card we can look at here, it's from Automation Direct, and as I told you maybe in the other video, this is not supported or sponsored by Automation Direct. In the AC digital input card, we have isolated channels. You can see our first channel has 2 connections, second channel 2 connections, and so on. And if we look at the internal circuit, which is I cannot stress enough how important that you examine the internal circuit for each card you are selecting. The AC comes back from your switch to a series of resistance and capacitance to your optical isolator. From this side onward, it's your card. From this side outward, it is your field wiring. If you look at the isolated channels, this is channel 1, channel 2, channel 3. Theoretically, you can look at them as completely separate circuits, meaning I can have for the first one 100 volt AC, The second one, I can have 200 volt AC as well. The other type of card you have common for a group of digital inputs. You can see here, this is 4 channels. Other cards have 8 channels or maybe 16 channels, all with one common. This is an AC input card. Again, you can see we have one leg or one, let's say this is our neutral, goes to C1, and the live side of my volt AC goes to all my switches, coming back to our channels. How you wire your PLC or your DCS? This is again our card here, and this is our card wiring. So you can see we have C1, C2, which is common for group 1, common for group 2, and then we have 1, 2, 3, 4, 5, and so on. The first 4 are associated with C1, the next will be associated with C2, and so on. So you have in your PLC a group of live and neutral terminals. Now you take one of those live side, you go a series in to all your outputs, connecting your switches, and then the feedback goes to your channels. Are you going to put fuses? Do we need fuses? There is 2 reasons to have a fuse: a protection or as a mean to disconnect your signal. So you can have a fuse on terminal 1, terminal 3, terminal 5. This will act as a disconnect only, because in normal operation you will have a short circuit. So I don't have any way to have a blown fuse here. Alternatively, you can have a fuse on L2 here. That means all the group of terminals or devices fed from L2 will be disconnected when you maintain them or do any maintenance for them. Let's look at isolated channels but a DC input card. If it is one channel, will be, this is how it looks like. But if it is a common, as we can see in this card, it's each 8 channels, they have one common. The only thing which is here in this slide you need to look at it is, you can see they showed us the battery or the power supply plus and minus, or it can be the minus plus. What does it mean? Meaning when you feed your 24 volt power to your switch, you can feed the positive side or you can feed the negative side. If you're feeding the positive side, that means they call it sourcing. And if it is you feeding the negative side, which is comes back, we call it sinking side. If you look internally to your card, the sinking sourcing type make your card from internally is absolutely looks like if it is an AC. The difference would be the resistance and the capacitance here, because they match your voltage range. This is an Allen Bradley or Rockwell digital input card. You can see they showed us something a little bit different. We haven't seen it before. They show us a 47 kilo ohm resistance across our limit switch or push button. Why they put this one here? What they did, they said, if you put a 47 kilo ohm across your limit switch or push buttons, our card will recognize the small current coming from your switch when it is in open position. And when you in the closed position, it will be a higher current. When we say current, we're talking about milliamps, in fact. So this case here, you can see you have 2 different levels of current or voltage coming through your system. If the voltage crosses the 47 kilo ohm comes back here, it will not be enough to turn your LED here on, but it will be enough to turn this LED. Then when you have a short circuit across your resistance, the voltage will be enough to power your LED, and then you will have a signal that means I have my input is on, and when you take it out, when you release the push button, the card will recognize that the wire, all the wire to your switch is intact and it is not open circuit. The reason is, if you look at it from a different perspective, your limit switch is completely open or completely closed. So if you have a broken wire, you will never be able to recognize you have an open wire until you push the limit switch or the push button, and you at the same time notice that your PLC cannot recognize the change of your channel. So this card will require this resistance. So even if this card give us more facility to recognize a cut wire, or open wire, we still need to insert this 47 kilo ohm across all of our limit switches, push buttons, selector switch, and so on. Delta V DCS, what they showed us here is again a positive and a negative. What does it mean? If you look at the LED inside your optical isolation, it has one direction only. So it can only receive the positive back from your limit switch or dry contact. Here they put something and they call it optional fuse. In fact, this fuse will not acting as a fuse for protection, because what's happened, if you close the limit switch, you will run everything through the wire as if it is a short circuit. That means this one will never blown fuse unless you have something like having a higher voltage, and then you will have more current here. This is an AC for delta V, and you can see here that they have it plus and minus. That means this is a live, this is a neutral, but you can see internally they have two LEDs for your optical isolation. Now let's move to the 3-wire switches, and you can see this is my proximity switch, and I'm sending the 24 volt to my proximity switch, and I'm receiving the yellow line is my signal back. In this case, what I did, I took the positive side, and it will come back as your input to your optical isolation to complete the circuit, and you will have 0, 1 when your switch change position. If you look at the limit switches manual, they showed us two things. This is your card or your load. In this case, it's connected between the minus and the signal. So your expectation that your signal will be the return positive from the limit switch. Here, the load is between the plus and the black, so meaning the black is the returning the negative side of your power. Now, they said that this limit switch or proximity switch will consume 10 milliamps when it is open, but when it is closed, that you can draw up to 200 milliamps from this type of switch. If you look at a P&F proximity switch, you can see they said the operating voltage between 10 to 36 volt DC, and then they give us something like the no load current is 12 milliamps. So that is between the plus and the minus, it will take 12 milliamps. Then when operating current, it is 100 milliamps. So make sure that your card will not draw more than the 100 milliamps. This card, they showed us the on voltage level is anything above 18 volt DC, and when the volt goes below 8 volt DC, it's recognized as an off level. So if your supply is 24 volt DC, see what is your volt drop across your wire from the PLC to the field device back to your card, and make sure you don't go below the 18 volt DC. Otherwise, it will never recognize that your limit switch is on position. Another AC card you can look at here that said the on voltage is when the voltage goes above 70 volt AC, and the off volt goes below 20 volt AC. This is another type of card. You can see here they said if you have a 24 volt source, I need the positive side on this terminal and the negative side on that terminal. That means if you can look at here, your 24 volt source is actually running your LED and the optical isolation unit, and that means you can feed 24 volt to this card and goes back to your source. Thank you for watching. Like and share, and please leave a comment. If you have any comment, please share it with us and let us discuss what you want to see in the near future or in the next video.